All right. Well, I have to say, I had to put the microphone a little away from my face because my talking was too loud, and then now I'm hearing a lot of traffic passing my office again. Maybe I shouldn't lecture in the afternoons. Um, so I apologize if you're hearing a lot of motor traffic in the background. All right, now, so we've selected our participants. We've recruited them in some fashion, got people from the population to join our study. Okay, now that we have our participants, now we have to figure out how to assign them to the condition that they're going to experience in our experiment. So in this diagram, we have children with autism. We have 10 children with autism. And from the 10 children who make up our population, this is obviously a small demonstration. So we got 10 people in the population, and we need 4 of them. So we select them. In this example, they were all willing to participate, and so we randomly selected them from the population of willing participants. That's one of the ways that psychologists can get around a problem with volunteers, which is volunteer bias, that people who volunteer might be somehow substantially different from people who don't volunteer. So what we can do is recruit a big pool of willing participants and then randomly select from that pool. That's what they did in this little picture. So from the 10 children with autism, 4 were randomly selected. Numbers 4, 5, 8, and 10 were recruited, were selected. Now we're going to randomly assign them to be in either the experimental group or the control group, which we'll talk about those words in a second, but I'm sure you guys have an inkling. These are the 2 different conditions that they're going to experience. In random assignment, everybody in the population, everybody in the sample has an equal chance of being assigned to either condition. Randomization means that everybody has an equal chance of being assigned to their condition. So when we have participant number 4 in front of us, we flip a coin, and heads they're going to be assigned to the experimental condition, or tails are going to go to the control condition. Or maybe we put all 4 numbers into a hat and we randomly draw them out without looking, and the first one is going to be assigned to the experimental condition, second one to the control condition, experimental control. That's a random way to do it. You could use a table of random numbers if you have a larger sample. There are a lot of ways to give everybody an equal chance of being assigned to either condition. I was going to say a roughly equal chance of being assigned to either condition. When you take statistics, they'll talk to you about the fact that when let's say in this case, you've got 4 volunteers, and you're going to be assigning them to 2 groups. Once the first person's been assigned to a group, the remaining 3 don't have the same probability of being assigned to either group as the first person did. But that gets into some pretty tall weeds in statistical reasoning, and it's really not relevant to our conversation. Let's just go ahead and say they have an equal chance of being assigned to either condition and let it go at that, and I'll let your stats teacher explain to you the details on the rest of that. But those of you who have already had stats might have already been thinking to yourself, well, wait a second. So I just wanted to clarify, yes, I know that, but let's not muddy it for right now. All right. Now, whenever you do an experiment, you're going to have variables. A variable is anything that can vary. Thank you very much for that clever definition. Yes, I made it up myself. Well, it really is. I mean, variables are anything that can assume at least 2 values. So when we talk about conditions in an experiment, you have to have at least 2 conditions, what we would call the experimental condition and the control condition, for example. For your dependent variable, you have to have some kind of measurement that will produce at least 2 possible outcomes. Yes and no, true or false, agree, disagree, or a score on a scale, or somebody's weight, or, I mean, there are a lot of things that you could use as a dependent variable, but the key thing is it has to be something that can produce at least 2 outcomes, or it's not able to vary, right? Okay, I'm going to talk about that a lot more as this slideshow goes on, as this chapter goes on. So let's not belabor the independent-dependent issue right now. I'm talking about experimental design. And so what we have to do when we're designing our experiments is decide what are going to be our variables for this experiment. That's the identifying part. So what factors do we think are going to be important? We have to identify those, and then we have to figure out a way to control them. I'm going to give you an example of an experiment that I'm designing right now, and I have a research team, and they are undergraduates, and so they have a lot more enthusiasm than they have knowledge, which is great. That's the function of the mentor, right, is to help out. So the basic premise for this experiment, some of you who are gamers might know what I'm talking about. Those of you who aren't are going to be going, I don't know what you're talking about, but that's okay because I don't either. My interest in this topic is at the level of perception. I'm a psychologist, and I'm really interested in how we process information. In this case, we're going to be doing a study of how people process visual information. Now, if you ask my research team, we're doing a study of, I have two research assistants who have very different goals for this study. One of them, if you ask him what it's about whether a gamer can detect the difference between images that are presented at 60 frames per second versus scenes or sequences that are presented at 120 frames per second. If you ask my other research assistant, they're interested in marketing issues, and so that research assistant is interested in whether the gamer notices the advertisements that are on the billboards embedded in games. So we've got disparate goals. Let's just focus on the gamer's goal. The gamer who's really interested in frame rate. We've been bouncing off of each other what the variables should be for this experiment. We have agreed that recognizing that it's 60 or 120 frame rates is going to be the dependent variable. We've agreed on that they can tell that it's 60 frame rate or 120 frame rate. Okay. Where we're having a back and forth discussion is on the independent variables. For one independent variable, obviously it's going to have to be that some of the scenes are played at 60 frames per second and some are played at 120 frames per second. Okay, we've agreed to that. That's one independent variable. See how it has at least two values, 60 versus 120. I'm going to launch Excel to demonstrate this for you guys, because it starts getting hairy pretty fast. So far, so good. So what we're doing right now is demonstrating how we identify variables. Okay, I do this in class too in case you're curious. So our first thing of interest was frame rate. And the choices are 60 or 120. Okay. Then that would be fine. We could just have one independent variable, and people who come in look at a series of a bunch of different trials. Sometimes the scene's being presented at 60 frame rate, sometimes it's at 120, and we could just see whether people can tell the difference between the 60 or the 120. But then we got to thinking about something that the research assistant had seen on the internet, which was a test that a expert gamer had conducted. And he did a little experiment in his studio where his friend set it up, and it would switch back and forth. The friend would set up either 60 or 120 frame rate, and then the gamer would come over, he would glimpse the scene, and he would say whether he thought it was 60 or 120. So there's only one participant, there were two conditions. It wasn't the world's greatest experiment, but what was interesting is that he could tell the difference between the 60 and the 120. He had zero errors in identifying it. But somebody else on the internet had also done a test, just again an informal test, and this person was not an expert gamer, and he couldn't tell the difference between the frame rates. So that got us to thinking that possibly being an expert versus a novice might be an important independent variable. So in my opinion, that's enough independent variables for a first experiment, for a first test of this question. I thought that was enough. But now my research team is starting to generate more independent variables. It's starting to get a little hairy. Let me put another row in here to show you how we can represent more independent variables. So now we're starting to get ideas like whether they are experienced experts or novices on PC games versus console games versus none. They don't play anything. So this would be all one condition. So you either are an expert or a novice at PC games, an expert or a novice on console games, or you don't play anything. Okay, I can support 3 independent variables. That's all right. I guess we can do that. My research assistant yesterday just told me one more idea that he had, and I you know what, I've repressed it, pulling some Freudian logic. I repressed it because I was like, oh no, we are not doing that on the first experiment. Let's get this one done. Okay, let's just collect this data and see how this one goes before we throw in another one. I personally think that this should be the first experiment. We've identified 2 independent variables, frame rate, which is something that we'll have control over, and then experience, which will be something that they come to the experiment already having. They're either an expert or a novice with gaming. I think possibly we should be looking at it like this, where we're only looking at people who play PC games and consider themselves experts or consider themselves to be novices. And then we present the 60 frame rate scenes, 120 frame rate scenes, and see if they can tell the difference among them. To me, that's perfect. But what I'm discussing here is we're still at the design phase. And so we're still trying to figure out what we're going to do on this experiment. What exactly we're going to, what we're doing right now is trying to identify the variables so that then we can move to the next stage and think about how to control the variables. So that's where I'm going to leave you for now, and then we'll come back and we'll talk about how we can gain control over the variables.